Every year, the monsoon season brings heavy rainfall across India. Roads become flooded, homes are affected, and daily life comes to a standstill. While most people notice the water itself, there is another danger that often remains hidden. A danger that cannot always be seen. A danger that can turn a flooded street into a life-threatening environment. When electricity leaks into standing water, the consequences can be severe. The danger is not always visible. In many situations, people are unable to recognize the threat until it is already too late. This raises an important question. What if dangerous electrical conditions in water could be detected automatically before an accident occurs? Hello everyone, my name is Tyron, and to address this challenge, I developed this project in water conductivity measuring and electrical safety system. The objective of the project is fairly simple: to continuously measure the conductivity of the water and respond whenever dangerous conditions are detected. This video will explain you about the probe, the conductivity, and the science behind it, and also demonstrate the working prototype of the project. Section 2: The solution. To address this problem, I developed AquaShield, an automatic water conductivity monitoring and electrical safety system. The main purpose of the system is to continuously monitor the conductivity of the water and take action whenever unsafe conditions are detected. The project consists of four major components. First, the conductivity probe. It is responsible for measuring the conductivity of the water. Second, the Arduino Uno, which acts as the brain of the entire system. Third, an LCD display which provides live conductivity readings and system status. And finally, a servo motor which is used to automatically disconnect electrical circuits whenever dangerous conditions are detected. The working process is fairly simple. The conductivity probe is placed inside the water and continuously measures changes in conductivity levels. These readings are then sent to the Arduino, where they are processed, compared against predefined safety thresholds. As long as the conductivity remains within the safe range, the system continues monitoring normally. However, if the conductivity rises beyond the threshold, the Arduino immediately recognizes the condition as potentially dangerous. A warning can then be displayed and the servo motor is activated. The servo rotates and mechanically disconnects the electrical circuits, reducing the risk of electrical shock or electrocution. The entire process happens automatically and requires minimal human intervention. In simple terms, the system follows three steps: detect, alert, protect. It is important to understand what conductivity actually means. Conductivity is the ability of a material to allow electric currents to flow through it. Some material, such as copper, are good conductors because electricity can pass through them easily. Other materials, such as rubber and plastic, are poor conductors and do not allow electricity to flow through them. Now let's talk about water. Many people think that water itself is a good conductor of electricity. However, pure distilled water actually conducts very little electricity because it contains very few ions. Ions are tiny charged particles that help carry electric current. In real life, the water we see around us is not completely pure. Tap water, rainwater, and flood water usually contain dissolved minerals, salt, and other substances. These create more ions in the water, making it more conductive. Salt water is a better conductor. When salt dissolves in water, it breaks into sodium ions and chloride ions. These charged particles move freely through the water and allow electricity to travel much more easily. To measure conductivity, a conductivity probe is placed inside the water. The probe checks how easily electric current can travel between two electrodes. If the conductivity increases, the readings increase as well. In the situations where electricity leaks into water, these readings can rise significantly. By continuously monitoring these changes, AquaShield can detect potentially dangerous conditions and respond automatically.